So I would like to give a policy background. I hear a bit of echo as well. So anyway, I will continue. So I was saying that the overall policy framework in this area is the Commission recommendation of 2021 on a common European data space for cultural heritage, which aims to help member states accelerate their digitization and digital preservation efforts, seize the opportunities of digital transformation, and share their data in the data space for cultural heritage. And I'm sure you're all aware, one particular emphasis in the recommendation is 3D digitization, particularly of cultural heritage at risk, as well as of the most visited monuments, buildings, and sites. So 3D is very important, not only because it can safeguard cultural heritage at risk, but also because embedding 3D in immersive environments can create engaging experiences, bringing cultural heritage closer to people, and in particular, young people. So sharing 3D content, digitizing in 3D, and sharing 3D content in the data space for cultural heritage for reuse brings all those opportunities for other applications in different sectors, creative sector, tourism, education, and other innovative sectors. So, quality of 3D digitization is very important, and the Eureka 3D project already has done great work in setting the foundation. Already before that, with the 3D digitization guidelines that have been produced as part of a study commissioned by the Commission. Also, in setting best practices, and also providing the capacity building opportunities to help cultural heritage institutions and other interested bodies to digitize cultural heritage in 3D. So I'm very happy that this event today brings together the community, and one step ahead, not only 3D digitization, but also using 3D in extended reality applications. And we all look very forward to the outcomes of this project. And we're very happy that this event will give a snapshot of what's in the making and what's being developed in this project. So I wish you a very fruitful meeting. I will be trying to follow as much as possible. I'm very interested to see the work that's being carried out. And thank you once again, and wish you a great event. Thank you very much for having me.
Thank you so much, Katerina, for the kind words and the welcome message. It is really nice to bring everyone together in events like this. And also, I'm really glad you're staying, Katerina, in this meeting, because today is the first time we're actually showing off the XR toolkit that's being developed in this project. So it's like kind of a premiere. We will invite Antonella later to the stage. So you will do it by heart? Okay. Thank you so much.
Okay, so first of all, Eureka 3D is an initiative, and it is an initiative that is made of two projects, Eureka 3D and the Eureka 3D XR. We started in 2023 to design an infrastructure for digital cultural heritage. So what is a digital cultural heritage? We heard from Katerina that digital cultural heritage means to digitize what is at risk, to digitize in order to create new experiences. But when the digitization is happening, then the content the data must be stored somewhere. and we are used to store our data on the server of the cultural heritage institution. This is the experience of the last 20 years. Cultural heritage institution have a good camera, take pictures, and put the files on their computer, or on their server, or on their cloud. But this works seamlessly when the content is 2D, when it is a JPEG file, and it is a TIFF file, a PDF file, when this is visible with the software that is available on our normal devices. When we move in the 3D, the situation changes, because in the 3D, the number of files that describe the object are many, and these files need to be elaborated by a viewer that is not the normal application to view a JPEG online. It is a complex application called the 3D viewer. And the 3D viewer needs to run closely connected with the data that is no more only one file, one JPEG, one TIFF, one PDF. It is a series of files. And we will hear about this in the next presentation. Secondly, thank you. Yes, but maybe I go ahead. Second, yeah, because I know the story very well. Just to say that. Thank you. So, secondly, thank you.
And backward.
Yeah. When we digitize in 3D, it is not only about taking a picture with the right light in the right position, but it is a picture. In 3D, we have to go around the object because it is a 3D. And to go around is more complex. It depends if the object is inside, in controlled environment, if it is outside, if it is a monument, if it is a statue that is outside, if the environment, which is the conditions of the environment, the light outside cannot be controlled as inside, if there is a wind, if it is cloudy or sunny. So there are a lot, which is the equipment that has been used. Because to produce 3D, the equipments are of many natures. So this means that we need to record not only the various files that represent the 3D geometry and the surface. Not only the metadata, we are used to have metadata that describe the object, but also paradata. The concept of paradata is already in the JPEG, because when you take a picture with your device, the paradata are stored automatically on the device, and there is a GPS position, there is the date of taking the picture. These are not the description of the object. They describe the way the digitization has taken place. But in the 3D, the paradata are much more important. And why all this is important? Because we said that we have two purposes for the 3D digitization. One is to register digitally that object that is at risk. It is at risk because of pollution, because of wars, because of tourism, because of time. So we have an option now that is to record our cultural heritage in a way that can serve restoration, as it happened in Notre Dame, or the memory of what has been done. Memory rings another bell. Because we are used to talk about the digital twin. The digital twin is a twin that represents the geometry and the surface, the texture of the surface of this geometry. But maybe if it is well done, it also disconnects an object that is made of different parts, and there is a 3D representation of its parts. But if this is only the geometry and the texture of the surface, it is not the memory twin. We are talking not about an aircraft that should be known from an engineering point of view. We are not talking about a building that we want to know from the architectural point of view. It is not only about techniques, it is about memory. Here we are talking about the 3D representation of a cultural heritage. And it is since the digitization of a cultural heritage started that we have the need to represent the object digitized in the context, in the cultural context, in the multidisciplinary cultural context that object hosts. And this means to have a memory twin, to have a twin that tells geometrical and surface features, but also the cultural context. So we prefer to talk about a memory twin, not just a digital twin. Well, all this is studied, experimented, prototyped in Eureka 3D. Eureka 3D ended at the end of December 24, and the major, most important result is the Eureka 3D Data Hub. Because remember that it is not safe that when you digitize in 3D, you deliver to Sketchfab. This is a practice that is very much used by cultural heritage institutions. It is not safe because in the terms of the services of the Sketchfab, you are donating your contents to Sketchfab, that is an American company with everything that we know about the transformation that is happening in America, in the US. This is an additional point to be taken into account. So our recommendation is do not use Sketchfab. What to use if it is not a Sketchfab? We need to put our data somewhere. Well, what we did was to develop a data hub, a place of storage and computing, because to manage 3D means storage and computing getting together, a Eureka 3D Data Hub that is not based on Azure, Amazon, no, it is based on the research cloud infrastructure, on the cloud infrastructure that has been paid, constructed with the money coming from taxpayers' money. This infrastructure is used by many sciences in Europe, and it is a time that is used also by cultural heritage research, which is not humanities research, it's something else. It has some specificity, cultural heritage research, that is different from historic research, archaeological research, all sciences that have their infrastructure. Cultural heritage research is missing a digital infrastructure. And we started with the Eureka 3D Data Hub. We are very proud that it works, and every day we receive requests of access to the Eureka 3D Data Hub. There is another valuable element in the story, that is quality. Quality of the 3D needs to be understood, needs to be planned. There are guidelines on the table that you can take in paper or you can download from the internet. There will be a full presentation from Professor Marinos Ioannides of Cyprus University of Technology, who has been the leader of a study paid again with the taxpayers' money. So we want that what has been produced with the taxpayers' money is actually used by the whole community. It is not intelligent that we produce results and then we forget and we start again to produce the same results, maybe of less value. So, two major components of Eureka 3D. The infrastructure, using the research, the cloud research infrastructure provided by the EGI Federation. I think even Bel-Spo participates in this federation, so it is applicable for Belgium as well. Belnet, in effect. And the guidelines for quality of 3D digitization. When we have the 3D, what do we do with this 3D? Apart from storage and visualize, we create extended reality experiences. And there are examples here, and you will get demonstrations in the rest of the day of capacity building produced by Eureka 3D XR.
Good morning, everybody. Who we are, because our name has to do also with the main mission of the presentation, also of the work that we are doing. Next, please. Our name is Mnemosyne, is the goddess of memory in ancient Greek mythology. Next, the goddess had 9 daughters. All of them had a special responsibility, a special job, and that was to preserve the memories and the knowledge of the ancient Greeks. They had a special place, a special temple, where the Greeks went to ask the ladies, please keep forever our memory alive. And next, please. And that was the museum, the so-called museum as you know it today. So a museum is a space of knowledge, a space where we preserve story and memory. Next slide, please. Next, therefore, when we digitize in cultural heritage, not in engineering, it's all about high quality of results. Next. It's all about authenticity and identity. It's not about the 2-dimensional and 3-dimensional structure of tangible assets. And that comes on the third position and not on the first. It's about materials and structural analysis. Of course, next. Is all about serving and taking into account the multidisciplinary community needs. Next. And of course, it's all about, as I mentioned in the previous slide, about preserving our cultural heritage memory. Next, please. You are in the edit mode. Yes. So, before we start the digitization, we need to ask ourselves, who, what, why, where, when, which, and so on. All the, whatever it starts with who. The who first. Who. Next, please. Who are you digitizing for? Stakeholder. Stakeholder had needs, please. Who is the primary intended user? The audience. The God. Next, if you can move, please, slowly. What is that will be digitized? What is the object? Is it the museum object? Is it a museum in the deepest part of the ocean? Is it a terrestrial place? What it will be used for? Next, please. What it will be used for? The why we digitize. Next. Next. Why is this being digitized? The motivation. Next. These are not trivial questions and if not considered lead to project delays, cost overrun, and low quality results. Next, please. And here is QR code of a report which has been fully financed by the European Commission, by the unit in which Katerina Moutogianni is working to establish a set of parameters about which we are discussing now, defining the complexity as well as the quality of the digitization, the 3D digitization in cultural heritage. Next slide, please. Next. So, it is all about the study. Next slide, please. So, fail to plan is planned to fail. We know it since years ago. A man who does not plan long ahead will find trouble at his door, from a very, very important and famous Chinese philosopher. What are the stakeholder here requirements? Because it's for them that we are digitizing. Next, please. Do you contact first the site? Do you go and see what the object is, the volume, the complexity, the object assessment? Identify and build your team depending on the complexity of the object, of the site, of the venue. Next, please. Solve legal issues and other barriers. Next. Create a detailed project description based on this, what it has been defined earlier. Agree on a recording methodology. Confirm the data capture solutions. Consider data storage, sustainability. Where are you going to store all this data? Locally, on the site, in the museum, on your server, on your laptop, on the laser scanner, on the cloud? Where? All these are parameters which have a certain complexity. Next, please. Estimate, of course, the complexity of your digitization. All this together. Next slide, please. Expectations, realistic, well-defined, they are appropriate. The deliverables are realistic. The data or products, level of documentation which is required, is it a high detailed documentation or is just a general one? Deadlines, realistic, achievable. What about the budget? How much money is going to cost us? Next, please. And here is where we define in this study the 40 parameters where we say that's the complexity. This is how complexity is defined. And here are the parameters from the stakeholder requirement: the time, the budget, the purpose, the location. Of course, as I mentioned earlier, is it terrestrial? Is it underground? Is it in underwater? Is it a cave? Is it in a museum? Is it in a laboratory? All the different places are very important and it's a part of the complexity. Next slide, please. What are the digitization conditions like? Independent from this, what it states there, it's also extremely important to take into account the weather conditions. Is it raining? Is it snowing? Is it windy? Are there sandstorms? What about the temperature? Having in mind the temperature, the factor, the parameter temperature, automatically you can understand devices cannot work at any kind of temperatures. Are there health and safety concerns? The logistics, transportation to the site, electricity provision, and so on. Imagine that it's in the deepest ground of the sea, the digitization. How you are going there and then to that location and from that point down to the ground of the sea. Next, please. Then the object complexity, state of the conditions, the material, the location again of the object, the dimensions, can I touch the object or not? Remedy options, which almost nobody takes into account. Next slide, please. Identify and build your team. Are they experts or amateurs? And if they are experts because of their experience or because they are professionals, they went to the university, they have been skilled because of this, what they are doing. Who else is needed so far as human resources concerned, and so on. Next, please. And here you see the parameters defining the team, the group of team. Next, please. Who is funding the work? Who owns the object? Who will own the data at the end of the day? Here we have parameters which most of the time during the digitization, they are underestimated so far as their complexity concerned. Next slide, please. What is the scope of the digitization? What is the objective of the digitization? What needs to happen and when? When it comes to staff availability, and imagine you are now ready to start with the digitization, but two of your members of the staff are sick, or an accident happened, or they are not on time on the place where there's a digitization has to start. Next slide, please. And here we are with the group parameters defining the complexity so far as the project is concerned. The coordinator, who is the coordinator? Do we have a coordinator? Do we have a management? Then the IPR, the deliverables, the infrastructure, the transportation, time availability, even during the day for the experts, the budget available for the project. Yes, next, please. Agree recording methods, so far as accuracy, resolution, the colors, who are we going to have a thermal, hyperspectral imagery, the scale is extremely important so far as image concerned. Then check equipment and software, they are up to date. And if we say about equipments, are your equipments calibrated from the manufacturer? When was that the last time? Yep, ask yourself before you start digitization. Confirm data capture solutions, agree with the stakeholders so far as the data formats concerned, the metadata, the paradata, the common lexicon of terms, informed team, write it down, and take care of your documentation. Next, please. For your digitization, the physical media, the backup, cloud access, they are where you are. Do you have a cloud access? Data security, of course, data safety, post-digitization, requirement for archiving. Do you take into account the FAIR and CARE guidelines, compliances, the digital preservation strategy, documentation, and of course your equipment. Ladies and gentlemen, here there is a very important issue. Imagine that you have one of the latest technology laser scanners with a bit resolution or bit and byte resolution of 255 or 256. So, and you are downloading your data to a computer with a 16 or 32 bits. What is going on there? Is your software in the position to manage all this processing, or you just forget a couple of bits and bytes? And what is going on with your accuracy, so far as the quality of precision, accurate, mathematically talking, of your data? Next slide, please. Of course, the complexity assessment and is your record showing due diligence and that the digitization was undertaken in the best possible conditions presented. Next one, please. And all about the colleagues, ladies and gentlemen, is under the group of 40 defined parameters, which now have been extended for the long-term monitoring of monuments and sites, with another one group, as you see it here, the monitoring, to be able for the long-term preservation to take also into account this complexity. Next slide, please. Now, we define the complexity. What's about the quality? The quality measures how the results of the digitization satisfy the specified set of requirements, depending, of course, in the complexity of the project. Next, please. The study, which we mentioned earlier, identifies 35 parameters, significant for indicators for accessing quality for the digitization results. Next, please. The aim of quality assessment is to evaluate the results of the digitization effort based on the metadata and paradata record and complexity assessment. Next. And of course, the quality assessment allows a greater potential for data use and reuse. And here is where we say that if and in case you want to prove that your digitization results are of high quality, then you have to take into account and deliver with the data a certificate of quality. Next, please. And this is your quality here. I would like to fly here through. I will give a copy of this presentation to everybody and make it available so that everybody can see it. Now, we are everybody is saying, here is my 3D model, and I want from that 3D model to know the point density, the completeness, the resolution, the geometrical accuracy, and the geometrical precision. Have you ever asked yourself, if you ever digitize an object in 3D, about all these 5 parameters? If not, then you have to keep a record and you have to give an answer to yourself first before you contact the owner or the stakeholder who gave you the contract to carry out a digitization. Next, please. Of course, the picture, even worse, the opacity, the clarity, the contrast, the resolution, the color depth, all these 5 parameters, who takes them into account during a digitization? Do you keep a record clarifying all these parameters here? Next, please. Scale. If a scale of your object is not in place, and it's a 3D object, then nobody can use that except you to satisfy your eyes and nothing else. So therefore, the scale, so far as these parameters, is extremely important. Next, please. Spectral analysis. Is it an X-ray, thermal, image fusion, absorbance, transmittance, reflectance, and so on? Next, please. And who is taking care of the materials in a 3D digitization? The chemical composition, the corrosion, carbonization, the porosity. Next, please. If it's a solid structure, 3D structure, then of course, at the end of the day, we are interested about the state of conservation, the diaphragmatic action, the connectivity of structure or structures, the quality of materials, strength and integrity of foundation. Ladies and gentlemen, that's all about so far as 3D documentation in cultural heritage concern. Next, please. Next. Yes, and it's all about to record all these parameters, and if we record them and have them together, then we come to a set of parameters, and that's our paradata. This is our certificate of quality. Next, please. Next slide, please. So far, so good. Then so what? Process your data into a workable 3D model, make it to be in such a place and condition so that others can work with that. Use a 3D viewer, a visualizer. Take always into account the IPR conditions. Antonella mentioned earlier the story of Sketchfab. Create a backup. This is an old story for whatever we do. Assign rights, publish your 3D models, and not only the 3D model, the metadata and the paradata with the quality certificate. Disseminate your project to your target stakeholders. Next, please. And here is the solution which it has been provided by the OERIC 3D, the previous project, which finished end of last year, from the capture to the cloud to the delivery, including e-archiving, including the user interface via Europeana, and including all the facilities to download standardized geometrical data.
Thank you very much. I hope you are having fun with all these technical difficulties. So I need to go a bit fast today. I'm sorry because we are short on time, so I will give you an introduction. But if you have any questions after this, please approach me and then I'll explain. So my name is Ignacio Lamata Martínez. You can call me Nacho, like the Mexican chips, but nachos with cheese, but I'm only one. I'm not the whole package. So I'm going to tell you about the Eureka 3D Data Hub today, and this is the picture, is the Eureka flow that Marinos was showing, and you can see here 3 phases: the capture, the cloud, and the delivery. So I'm going to talk about the cloud, but I want to put this in context, so you know where we are in the picture. So we normally start with a real object that we digitize in the process, and then we extract data, metadata, and paradata. And this is very important because, as Antonella mentioned, we are not trying to collect only the geometrical, so the shape of this chair. We are trying to get the memory of the chair. So we are trying to collect the whole history behind the chair. Who created it, how, what it experienced during its life, so everything about an object. So it's not like we are digitizing something and capturing something for a game. It's something deeper than that. We are trying to collect memory. And that's why we collect data, metadata, and paradata. So once we have these 3 types of data, we upload it into a European cloud. This is an important point that Antonella mentioned, that we are not Sketchfab. So we are using EGI infrastructure. EGI is a federation of different national providers. So we have all the providers in the national governments of Europe that can provide these services. In this case, for example, now we are using Poland, Cyfronet, which is a governmental organization in Poland, and, but we have many sites around Europe to store this data. So then we have 3 phases. So this is the Eureka 3D Data Hub. The Eureka 3D Data Hub allows you to store, manage, publish, and share your data. And publish especially in Europeana, which is very important. And we can do this in your data, metadata, and paradata. As you know, as they mentioned, metadata is the data about the object, and paradata is the data about the digitization process. What did you use? Which were the conditions were there? If it was humid in the room when you do the digitization, because all these parameters matter in the quality of the object that you input here. So there are 3 components here. One is the authentication and authorization. That is very important to ensure that everything that is there is secure. Then the data management, and then the compute power. We are using B2Handle to get persistent IDs. So when you publish in Europeana, your object receives a persistent ID. It's an ID that lives for the long life of the object. So, and this B2Handle is a European initiative that is allowing this. And then we go to the delivery. And to the delivery, we have different options. We have the Europeana user interface. We can download the data and do some other things. And of course, we are integrated with EOSC. So everything we do here is towards EOSC. So how this fit in the whole Eureka 3D context or in the ecosystem. So this that you see here is the data hub. On the right, these 2 boxes. This is the Eureka 3D Data Hub, and this is the new XR that will be explained later, but this is the infrastructure that will be used for XR. So basically, all sorts of XR applications that you can use to access the data and to manage and to do different stuff with this data. So this is just to give you an overview, and now I will go for the demo. That is usually the thing that always fails. So I'm happy that this time it might work. So I'll quickly show you these 3 parts that I explained here. So basically, the access, the data management, and the publication in Europeana. So we have this system. You can see we have this Eureka 3D logo in 3D, actually in actual 3D. So this is the system. I'm going to log out so you see the whole process. So when you get to the Eureka 3D Data Hub, the first thing that you see is this EGI Data Hub. That is a system that we manage. And then you have here the sign-in. So this is where you get your access. This is the first system that I explained here. So this component that says authentication and authorization is this one. You get here, and then you can log in. To log in, we will use EGI check-in. And EGI check-in is just a proxy. So it means that you can use your credentials from your institutions to log in. So you don't need to create an account in EGI. You use your own credentials, so from the University of Oxford, from your research institutions to log in. If you don't have any, so for example, if I look here for Oxford, I get Oxford Brookes and University of Oxford. If I click here, I can log in with my usual account in my university or my research institution. There are many here because this is from EduGain, so you can get even universities in China and some other places to log in. And then you can use also, if you don't have any research institution or affiliation to them, you can use Google, ORCID, GitHub, any other account. So in my case, I will use EGI SSO. I will input my credentials. I accept. And now I'm logging. So this is very good because we have single sign-on. So if you go to your research institution and you log in to check your email, you don't need to do anything to access this. You just click login, and automatically you don't need to input the password. You are already logged in your institution, so you get here. And this is very important because you don't share credentials with Eureka 3D. You share it with the organization that you really trust. So it could be your university, it could be your research institution, so you don't share this password with us. You just use your institution to log in. So this is the first aspect, and this is all compatible with EOSC. EOSC is the European cloud promoted by Europe, so the Open Science Cloud. So it's all integrated with that. So now we get to Eureka 3D Data Hub, and you can see here we have this Eureka 3D space here, and you can see all sorts of projects from BIBRACT, from CAT, the Cyprus University of Technology, Girabol, Photo Consortium, Museo de la Carta. So how we create a project here. And I'm going to go a bit fast on this. I wanted to give you a better understanding, but yeah, I will go a bit fast. Okay, so I'm going to create a project. A project is this source where we input all the data. So we can say, for example, St. Mary's Church, let's say. So this is the object we are digitizing today. Okay, then I run the workflow, and it's working on this to create the structure, the organization of the project. So it's going to map the project name, then to create the root directory, then it will do this. You can see that it's becoming green down here. So this is the action it's doing. And okay, when it's done, you will get a finish option, and then you can get here, and you will see that St. Mary's Church has been created now here. So originally we create this organization, but you can use your own organization. This is based on the VG study. I think it hasn't been mentioned today, but it's a very important study promoted by the European Commission. So please check it out, and you get this organization here to store your data. So to input the data, actually here is very simple. You just get your models. For example, I digitize the Eureka 3D logo here. I just drag and drop. It's as simple as this. I mean, everyone can use it. This is nothing really fancy about this. So you just click, drag, and drop, and then you get the file. This is also a preliminary structure, but you can organize things as you like. So you can say, for example, I want to create the chemical analysis and store it in another folder. So you can do it here, and you can create a folder, and you can upload here the data that you like. Whatever it is, you can put it here. So it's a convenient way to store all your data and to manage the data. You can also create metadata for these details. So you can have metadata in different formats. You can have key values. You have JSON. You have RDF. So there are different formats that you can input metadata in here. And then I will tell you about the publishing. So the publishing, imagine I uploaded here my 3D model, and I want to publish it into Europeana. I go to the publishing. I create an open data object, and then I choose the PID service. In my case, well, normally you only have one, but I'm a super user, so I have a lot of them. So I'm going to use B2Handle to provide a persistent ID for my object, and then you choose the metadata format. So I use the Europeana data model, EDM. So this is the model promoted by Europeana for cultural heritage. So once you proceed, you can input here the information, the metadata about the object you digitize. So you can say, okay, this is the St. Mary's Church, for example. You can add a description. And you can do this in different languages. So you can put it in English, you can put it in Greek, German, and then you can have multiple descriptions as well. So you can have one in English, one in your local language, for example. And then you can fill all these details about the object. I'm not going to waste much time on this because we are short in time, but anyway. So once you get all the metadata published here, so you can use this form, or you can use the XML if you are an advanced user. If you prefer it, you can directly use the EDM format in the technical way. But I always recommend to use the visual because it's much easier. And then you can also get these different combo box that helps you to say, for example, the material I've used is stone or things like that. Once that, you publish this, and when it's published, you will get, okay, you will get this data to Europeana. So Europeana is able to capture the data. And this is more or less how it looks afterwards. So you have the object that you uploaded that you can visualize and you can work with it. Like this one, so you get this vision, this viewer, and then you get all the information, the metadata that you publish. So you have all the metadata here, and everything that you provided in the form is shared with Europeana, and Europeana can share it to the final user. So you get the visualization and you get all the data. And finally, we have also a content provider handbook that is a very nice document where we explain, it's a user manual, where we explain everything in detail, what you need to do to be part of the data hub. From the time that you need to configure your access to how to modify things, upload data, change things, create projects, share it, publish it, because there are many ways to share it actually. So you can actually not only share with or publish in Europeana, you can get any file here or any directory, and you can click and share. So I can get, for example, this St. Mary's chart that I just created and say, okay, I would like to share it, and you share it, and people can use this URL, this address, to go here and check the object. Even though they are not in the data hub and they have no permissions here, you can share it publicly with anyone in the world. So you can say, okay, I share some files, or I can share whole directories, things like that. So basically, this is a summary. If you have any questions, please approach me after this event, or I can show you in more details because I have to be very fast. I hope my time was okay. So thank you very much for your attention.
Okay, good morning. Good morning. After these technical presentations, now you have an idea of what are the fundamentals for this project. And now we start with a presentation of the different scenarios. Like this, you have an idea of the possibilities for cultural heritage institutions to use these technologies on 3D and XR. First of all, I will present, I am David Ignacio from CRDI, that is the Photographic and Audiovisual Archive in the City Council of Girona in Catalonia. We have been working in this scenario. This is the virtual visualization of the Girona historical walls, and the company that has developed the tools and that will explain this scenario are Swing IT. But just a short introduction. And I would like to focus on to highlight three different aspects of this scenario. One is that is done by an archive, so 3D can be used by archives, and we'll see that the importance of having 2D documents like photographs that are the base to reveal some elements of the heritage, in this case the walls, that disappear in the past. So archives are part of this, archives are able to use this technology for their purpose. The second aspect is that we have an experience. It's not the first project, it's the third project on 3D. So we consider a benefit of using this technology, and we are exploring new ways of using this technology. And the third aspect that is very important is that for working on a project like this, you need always a methodology and an infrastructure. And this project, Eureka 3D, offers, as has been explained before, a methodology that is the BG study and the guidelines developed in the project for digitization, and the infrastructure that is the data hub that was explained by Ignacio. So, for you to have an idea of the scenarios, what we want to do is to make a visualization of this part of the walls that were demolished. You see all the walls, this area of the walls with the bastions that now is completely full of buildings, etc. So we need to create something in order to visualize all this extension of walls that is a big part of the city. For you to have an idea, a bit of context, is that the walls started with the foundation of the city in the Roman period, that the main part are medieval, but then there are the period when the bastions are built and the towers, that is 16th, 17th century. And at the beginning of the 20th century, the walls, part of the walls are demolished because the city wants to expand. That it happens in most of cities in Europe that had walls. And then in the 80s, in the 20th century, start the process of reconstruction of the vestiges of the walls. In this city, we have the part of the walls that are on the mountains that were kept. So they were reconstructed physically, but the parts that were in the flat area were demolished. So we focus on this part that were demolished. And what are the challenges for the cultural heritage institutions for a work like this? Four main challenges. One is to have a knowledge, deep knowledge of the city, of the historical evolution. And in the case of the city Girona, there is a group at the university that started working with urban history in the 90s. So they publish 15 books. So we have a very detailed information of this, and this is essential. Then to record original records, to gather original records, sorry, in order to have very precise information of every element, where it's located, what are the vestiges, etc. Then to provide images for the new tool, old images from the archive, but also new images, because in this case, as I mentioned, we have part of the walls that are still kept, so we can work also on new images. And very important also challenge to have aerial images. In many countries, there are these national projects that they are taking this aerial data, LiDAR data. However, we check it and these images, and we realized that the detail was not enough. So that's why we proceeded to hire a drone company, and with the instructions of our colleagues, we took new images with a drone. And from here, we start working on the XR experience. That's what they will explain with the tool. We create a narrative, of course, because we decide what is explained, and that's all. You will see now the results, part of the results. And just to mention that for the City Council, it makes sense because there is a project that considers the use of 3D for explaining the city. So we are in this process, so the Eureka 3D fits very well in this general project of the City Council to use 3D for explaining the evolution, the urbanistic evolution of the city.
So thanks, David. So I'm Marco Falciglia from Software Engineering Italia, and this is my colleague Gianpaolo that will talk in a bit. So these are our contacts, so please, if you want to have a chat later, contact either me or him. So the two tools we are developing for, okay, something stopped working, okay, thank you. So are the AI 3D Builder and the 3D XR Studio. So we start with the first one. There is a quick overview of our work. Yeah. I think there is an audio, but I don't know. It's been muted or something. So all of this is connected to the speech of David before. If you remember the Girona walls, so the idea is that a visitor, like a tourist, can see in his device or the music that was planned to start 1 minute before, can visualize in his device XR reality, like the walls we mentioned before. And now I will explain a little bit how this works. So yeah, the first tool is called the AI 3D Builder, and it's basically an optimized 3D modeling pipeline that is supposed to help cultural heritage professionals to obtain optimized 3D mesh, starting from photographic sources, and without any prior knowledge of 3D modeling. So we chose Trellis, which is a tool developed by Microsoft for several reasons. One of them is that it has a free commercial MIT license. The results were quite encouraging. Also, it allows in input multiple images, so if you give more perspective, it's more likely that the final result will be good enough. And it helped us to have a local deployment of the API we're installing right now. So it's quite easy and very quick to generate this kind of results. So, of course, we provide an extensive guide about the best way to provide the pictures, like to have images as sharp as possible with the bird view perspective. And these are the drones we rented in Girona, as David mentioned before. And so let's say that we want to recreate a 3D model of this bastion in particular. So the first step is actually to select accurately the outline by using photo editing tools. And after we obtain a quite good result, we can put the resulting image by ignoring its backdrop and putting it in input in Trellis. After that, there are several parameters we can tweak. For example, we are using the maximum number of sampling steps and guidance strength in order to have a more reliable result. This is the preview we obtain. And we also put to the maximum the texture size and the simplify parameter to avoid decimation. This is the kind of 3D model that we can download. The whole process is very short. And after that, of course, there might be some minor flaws. So we can open the resulting model in 3D software like Blender and make sure to avoid the flaws like missing gaps or not wanted 3D parts. We can then select accurately the 3D texture and choose in a smart way the specific points to use in order to have a correct UV mapping. Yeah, for instance, increasing the brightness allows a more refined and appropriate result. This can be replied several times for each of the parts composing the whole structure of the walls. So what our colleague did was doing this repeatedly for every single part and then joining them accurately according to the map layout that David provided in his documents that were very useful for our job. The second tool we are developing is called 3DXR Studio, and it allows there are two sets of people involved, like the 3D cultural heritage professional. They don't need any coding skills, but they can create in their archaeological sites a sort of path guiding visitors, tourists, and in order to give an engaging experience to enhance the discoverability of the Eureka paths, artistical places and monuments and so on. And so it's basically based on the two components that are tightly connected between each other, the web one and the mobile one. In a few seconds, my colleague will talk about the web component. And yeah, so Gian, I give you the room for your part.
Thank you, Marco. Chi è che va avanti? Hi, everyone. I'm Gianpaolo Donnarumma. I'm working as a technology integrator and software developer in Swingit. Yeah, you say how to produce a fantastic 3D model of cultural heritage, but now we can see how to use it, what we can do with this 3D model. Our idea is to let the tourist to enjoy a really engaging XR experience. With our application, developed, in fact, for curator, the user, without particular technical skills, can manage and then design what we call an XR environment. Inside an XR environment, you can place the 3D model created, as you've seen a minute ago, and then enrich the experience with information, point of interest, and also a path route that the tourist can follow in order to engage the visit as you have kept it in mind. What our idea is to develop a web application so the user don't have to install particular software, and they can use it also from our mobile device. The interface is modern and intuitive, and you can, as you see on the screen, import directly the model, and with a few clicks you can place it on a map. And then, as you see with this blue dot, you can also click and design what we call the path route, and then, as you see, this little pigeon here is a point of interest that you can use to enrich of information the experience of the tourist. Now, my colleagues can talk you about the other components, the mobile components. What we say a minute ago is that the web application take all this information that you placed inside and on the map and share it with the mobile component. Thank you for the attention.
Thank you, Gian. So, yeah, so there is basically this mobile component that allows us to do most of the same functionalities as of the web component, but also it allows some fine-tuning. For example, there is a model and then you can shift the perspective a little bit, and I'll show you a video in a few seconds. One thing that we wanted to point out in this slide is that our technology doesn't require any environmental scans before of the archaeological site. We don't need to rely on recognition pattern. We don't need, during the visit of the tourist, any internet connection whatsoever, neither GPS. So it's quite free and customizable. The only necessity is to actually have the device, such as a smartphone, precisely aligned to the specific point in order to have all the models aligned correctly. So these are the main feature of the mobile tool. So this is the curator view. So there is a sort of a tracking in red of the walkable area. We can choose one or more models to put. So this is the Pisa Tower. We are kind of rotating it, scaling it, translating it, and when we click on a model, it becomes highlighted in yellow, which becomes useful if there are multiple models in the scene. Also, there is this kind of red line that is useful to enhance the distance from the walkable area. And we can delete anytime any model. We can add them as more as we like. And, but one thing that we find particularly useful is in this case, for instance, you can see how the 3D model is a little bit not pleasant to watch because there is a real obstacle. So we can simulate occlusion by putting that wall that we saw a few seconds earlier. So if we switch from the curator point of view to the final end user, so the kind of visitor or tourist enjoying the XR experience through the smartphone, the model looks visible only when there is no obstacle in front of it. And yeah, there was the mannequin piece. Maybe some of you recognize it. So another option that we have, as Jan pointed out, is the option for cultural heritage professional to create a suggested path for the tourist. So at any point, we can create any white dot, and each of them has an increasing number next to it. We can delete, edit, or add whenever we want a new dot. And all of these dots are connected together in a very bright red green curve that you can see right now. There is a map that allows to identify all the models and all the paths within a reachable distance. So this is the kind of view that the tourist or the visitor will have through their smartphone. And the final feature that we want to show you is the option to set in any point an interest point. So if you click on the lamp icon, you can see this pigeon right now. So this is a kind of placeholder that shows that in that specific point, that might be something interesting for the visitor. So clicking on that UI icon, we can see how the visitor will see. So clicking on the pigeon, an audio guide will start right immediately. And after that, any kind of augmented feature, such as text, images, video, hyperlinks, and so on, can be set by the curator in order to point out the reason of that interest point. So I think I'm done. Thank you for your attention.
So my name is Irene Caldelli. I'm a senior researcher at the National Technical University of Athens. And together with my colleague, Agathe Leriche-Mogy from Bibracte, we will describe the collaborative work that we did between the team of software developers and engineers from National Technical University of Athens and the team of culture heritage professionals and archaeologists from the Bibracte archaeological site towards designing and implementing a pair of tools that allow you to prepare and visualize AR tours, and also provide an overview of how these tools are being applied at the Bibracte archaeological site. So the main objectives of this scenario are first to enable cultural heritage professionals and curators to design AR narratives by selecting, curating and contextualizing cultural heritage objects that they can find on online repositories such as Europeana, the Eureka 3D Hub, or other cultural heritage organization specific repositories, put them together and define a tour via an open and reusable web platform. The second objective is addressed to the on-site visitor, so this curated tours are served to visitors of archaeological and other cultural heritage sites in a lightweight and smartphone-driven way, so without the need of any fancy devices. We want to test and evaluate the technical tools on the Bibracte archaeological site, since this is our main case study to see how this work on a real world scenario that aims to reveal what is no longer visible at the archaeological site. So the objective is to highlight the potential of the tools and also serve as a case study for the future uptake in other contexts. So I will start by providing an overview of the tools and their architecture, and then Agata will describe the scenario. And we will conclude with discussing some challenges that we encountered. So this is a high-level overview that shows how the different tools interact with each other and with existing online repositories. So on the left side, there is what we call the AR Tool Builder, the web platform addressed to the curators, which allows them to access available assets on online repositories, put them together and pin them on points of interest on a map, and add contextual information such as descriptions, textual descriptions that bring all these assets together in a comprehensive narrative. And then all this information, the assets, the content, and the metadata are stored in a centralized database, which is accessed by the mobile phone of the on-site visitor via a mobile app that works for Android devices at the moment, which is called the AR Tour Experience app, and is based on GPS tracking of the user as opposed to the previous application that was presented. As soon as the on-site visitor approaches a certain location, as indicated by the AR Tour builder, they are prompted to visualize certain assets associated with this point of interest, with a particular emphasis on AR views, so as we will see later. So 3D objects presented in the physical environment as captured by the visitor's mobile camera. The AR Tool Builder is still under development, the user interface at least of it. Here we can see some indicative screenshots. So there is an asset library that allows users to organize the assets they have selected from different repositories. This may represent different types of content, images, 3D objects, audio, videos, whatever. And then they link them to points of interest by adding also some location-specific descriptions. It's important also to mention that there is support for multilinguality, so contents in different languages can be associated with a certain point of interest, and the user then, when the AR Tour is served to the end user, can select the language of their choice. An important thing to mention is that all functionalities supported by the platform are exposed via an API, which is important because this reinforces reusability, so any third-party application, another mobile app maybe, can make use of all the functionalities regarding assets management, user management, tour creation and editing, and so on. So let me now move on to presenting the AR Tour Experience app, whose first prototype is ready and was tested last week actually at the Bibracte site, so we will see some early results that we have achieved. The general workflow works like this. You first select a project, so a site, and a site may support more than one tours. There might be tours addressed to children, for example, tours for visitors who have a longer time available, or shorter tours for those who want to hurry up. And then the user selects the tours and starts navigation. There is support for guided tours or free tours where the user can roam around and approach several points of interest of their selection. And there are different views associated with different types of assets and content, as we will see. So we use OpenStreetMaps for navigation, and we also plan to support the possibility to position other maps such as LiDAR or historical maps on top of the OpenStreetMaps if this is a choice of the curator via the AR Tour Builder. So a point of interest can be associated with multiple assets. Okay, 3D objects are our first-class citizen. It is also a usual case, at least in the Bibracte scenario, that a 3D object comes together with an audio that explains what you're seeing in the 3D model. It can be a point of interest, can also be associated with images, videos, textual documents, and includes links to external content, for example, quizzes that the curators have prepared via a different platform. So there are two basic view modes that are supported by the mobile app. One, visualization on a 3D viewer that is manipulated via a touch screen, so you can zoom, rotate, and so on. And this is more appropriate for special kinds of 3D objects, such as exhibits that are currently in a museum, for which it may not make sense to overlay them, superimpose them on the physical environment. And there is an AR mode via which the objects are overlaid on the physical environment. And in this case, the interaction takes place via the way the user's body moves. So you approach an object by moving closer to it, and you can go around it just looking at your camera. And there are two cases that we're considering in this case. There are objects that need to be anchored on a very specific place. For example, in case of reconstructions, they need to be positioned at very specific places, or backfilled excavations, and therefore georeferencing information needs to be appropriate encompassed in the model. Or there might be cases where the curator thinks that free positioning is more appropriate, for example, to visualize an artifact that is currently in the museum in their physical environment where it was originally discovered, for example. And let me now give the floor to Agata.
Thank you. Good morning. Bibracte was a Gallic town from the 1st century before Christus. The site was discovered at the end of the 19th century, then neglected, and then with a great excavation since the 80s. But if there is a lot of artifacts displayed on the museum, there are very few remains on site for many reasons. In this slide and the following, present what is not or no longer visible today, especially the remains of Gallic wooden building, because the wood is not preserved over the time, and the remains are destroyed during the process of excavation to go under or backfilled afterwards. Also, excavated structures, of course, to prevent them from collapsing or to protect visitors. We have also the post halls of Gallic public buildings, post halls now backfilled, but which have allowed archaeologists to make hypotheses of the elevation of the buildings. On the archaeological site, we have also visible remains of buildings using Roman techniques, but the state preserved and shown to visitors is often the latter states of the building, which cover the previous states now underneath. And of course, we have also other realities non-visible, such as technical, economic, social, and natural evolutions. But with this European project, and thanks to augmented reality, we have now the possibility to show these non-visible realities through an AR tour, the hidden side of Bibract. We choose the point of interest according to 3 criteria. First, their potential to illustrate these non-visible realities. Also, the availability of 3D models, especially because 3D models, with a few exceptions, will be the main content of each query and the argument of their narrative. And third, the existence of complementary and engaging media to tell this narrative and to highlight the full potential of the tools. Currently, we have planned about 10 points of interest. 4 of them were tested last week with Ioannides, a colleague of Irini, and especially this one, Euphoria Dump It, you saw in the former slide. 3 other peri are well prepared with their complementary media, and for 3 others, we will need to use the ARI 3D Builder to convert 2D on 3D. And we have also interesting and specific cases in terms of content and location. As I told you, for 1 and perhaps 2 points of interest, we don't use 3D models as main content, but historical photo of landscape, photo georeferenced and oriented, in order to the visitors will be able to see this photo only in the right viewing angle. And as Irini told you, some point of interest will propose quizzes. Quizzes designed and available in Historiana. Historiana is an online platform developed by Euroclio, an European association funded by European Union. And on this platform, you can find resources and e-learning activity for teaching and learning history. And third, we have some points, little sensitive, points that are very close. For example, rooms in the same buildings, or how to access, for which we manage the precise activation to declench the point of interest. And Irini, for the conclusion.
Yeah, thanks. So I know that time is running out, but I think it's worth it going over some challenges that we encountered, because I think they share some common concerns that other endeavors and initiatives and other ecological or culture-heritage sites may encounter as well. So first of all, one issue that we experienced has to do with the fact that certain locations had limited or no connection to the internet, which is a problem because you cannot download the 3D model on your mobile phone or whatever other type of content. So the way we are dealing with this issue is that we urge the user to download the tour in advance, for example, at the entrance of the site where there is good signal. Also, we had issues with the exact positioning of certain 3D models for which this is necessary. And this had to do with the fact that inadequate georeferencing information was associated with the object. So it's important to communicate to curators what exact level of georeferencing information has to be associated with the 3D model. And also, the storing and maintenance of 3D models requires non-negligible storage resources, which we had not available in this project. So the way we dealt with this is that during the AR tour creation, curators, the user only puts the links to the 3D models that need to be hosted by another repository, for example, the Eureka 3D Hub. Another limitation that we experienced during our testing at Bibracte last week, it became evident when we actually tested the mobile app on site, had to do with how should you visualize in a meaningful way structures that have underground parts. And this is quite common, especially for ecological places. So it looks sometimes awkward if you approach these structures from the site and you see like their underground parts. Why they look meaningful if you approach them from above. So you see the excavation pit or the mine shaft as you see here. So the way we planned our plan for dealing with this issue is to display the models only when visitors approach them and hide them when they move away so that they don't see the site, so that it looks more realistic, like a hole on the ground. And let me conclude with the next steps that we have planned. So we, in light of the feedback and testing results at Bibracte, we plan to apply several refinements to the AR Tour Experience app. And of course, we have to complete the design of the user face of the AR Tour Builder because this is necessary to allow us to test both tools in combination. So prepare an AR tour, test it on the ground, and iteratively refine this process. Of course, the preparation of all content and information for the tour also needs to be completed and entered on the to the AR Tour Builder. And until the end of the project, we intend to perform iterative testing and evaluation on site with stakeholders, and also towards the end of the project with real visitors to receive insightful feedback. And let me just mention that we will be over there with our mobile phones for those of you who wish to see how this app looks like, or if you have questions. Thank you.
So, ladies and gentlemen, this is my country. This is Cyprus. This is the island of Venus, of Aphrodite, of love, of beauty. And there is the location of the San Neophytos Monastery. Next, please. This is exactly the location, the place, as we see it from the satellites, from Google Maps. Next, please. This is the complexity of the monastery. Next one. This is a 12th century Byzantine monastery. Next, please. And this is how it looks. It's a part of the hill. This is the Enclistra. This is the cave of San Neophytos, the place where he spent several years of his life. Next, please. So, Saint Neophytos, the recluse and the time of his life. And here is as it is presented in a fresco in his Next slide, please. Next, please. The structure again. And if we see the interior, then it's visible that there is a problem also in the structure. Next, please. I mentioned to you earlier, next. Yes, thank you. I mentioned to you earlier that if we digitize, especially in the third dimension or in a third dimensional space, we don't digitize only the geometry. It's also the pathology. And here you see cracks and damaged areas. Next slide, please. This is a part of the interior, of the beauty of the cave. Next, please. Here you see again the sand, the frescoes of the Enclistra. Next. The point cloud from the exterior. Next. Next, please. And from the interior. Next, please. And of course, the three-dimensional model, the structure in different formats as it has been processed, even for a 3D print. Yes, next. Next, please. Next, please. Next, please. Next, please. Next, please. You see here the different stages from the digitization, the exterior and the interior in 360 degrees images, then the UAV capturing. Next. And of course, we mentioned that earlier. At the beginning, Antonella said it, I mentioned it, and of course, Ignacio. If we digitize, if we do a three-dimensional documentation in cultural heritage, we don't do it just only for the screen, not only for gaming. It's for the multidisciplinary, interdisciplinary, and intersectorial user community. So one 3D model to serve all the needs of all this community here in the case study of San Neophytos, Cyprus. Next, please. And because we talked earlier about the complexity and the quality, the implementation of the EU VG 2020-654 study, the complexity and the quality of this data acquisition. Next, please. Next. And here is a QR code. I'm kindly asking all the colleagues online and in physical presence to scan the code, because I am not present there to show to you the virtual tour in the cave. It's better if you do it so that we can catch up with the time. Please scan the QR code. Now, we have the transport. The viewer is going back to the time of San Neophytos, 900 years ago. From today, from the 21st century, we're going backwards to the 12th century. The recreation of the Enclistra. We populate the Enclistra with digital representations of the monks. Pay attention. Stage a partial recreation of San Neophytos liturgy in the virtual space. enable the real monks to tell the history of the Englistra, and allow the viewer to ask and communicate digitally with the sun. Next, please. We bring the entire knowledge together of the story of the life of San Neophytos, and on that place in the virtual dimension by the full power of the Oerica 3D and its extension, the Oerica 3D XR project. Next slide, please. And now, ladies and gentlemen, we are in the position to do what? See here what I have in my hand. This is a sponge. Assuming that this is the Englistra, this is the cave, then I will do something here, which is extremely important. You see, this is a cup, this is a coffee. And you see here what I have? This is exactly the same three-dimensional structure, the 3D object, the sponge, but you see already a color there, a liquid. Assuming that this liquid, this coffee, is the intangible story. This is how we embed the intangible to the tangible, to the 3D. And this is exactly what we are going to do with our case study here in Cyprus, aligning with the fair and care principles, and of course with the Sevilla and London Charter. Next slide, please. We include also, we don't leave by side those who are currently there, present there, the monks. We include their stories and, of course, the story of the sun presented here in this icon. The sun is going to talk, to communicate with all of you. Next, please. And here is his sarcophagus. Yeah? We bring the sun back to life, 900 years. And this is for us to use based on high quality of three-dimensional data acquisition. I'm not using digitization now. Data acquisition, because we have different forms of data here. We bring all of them together, and with the power of the current technology, the AI and the XR, we do what? We transfer the knowledge of the past here to the present. This is the momentum when we say, let the monument talk. Let the sun to tell us his story, to send us out his message. That's the mission of the digitization of the past. This is for us the digital reconstruction of the past and the digital documentation. Now, if we go a step further, you see here a satellite image of the monastery. And because we do a holistic approach, so far as our documentation concerned, ladies and gentlemen, I would like to show to you something else, which is important, and it is included in our documentation in this pilot. And this is what we understand from this part of Europe, what the digitization of the past means. Next slide, please. We use another one service of the European Union, the European Space Agency's Sentinel 1A and 1B satellite services to do what? Next slide, please. To capture the ground degradation and the ground displacement in the area. Have in mind, Cyprus is moving. We are in an earthquake area. Next, please. Next, please. And here is where you can see over the time, over the different decades, that the monastery already moved, the entire monastery, not only the Englistra, the cave, moved. And we see here some slides, please. Next. You see an average of 8 millimeters per year on a horizontal displacement, on a vertical displacement of 3.2 millimeters per year. Do you know what does this mean? This is an alert. This is the bell is ringing. Our story of the past is in a very dangerous condition. Next slide, please. And here is where we say we take the power of the advanced technologies of the 21st century to transfer not only the knowledge, but also to document in such a detail, to give it to the multidisciplinary society, transfer it to the multidisciplinary society to take action, to take the appropriate measures to save first, to preserve for the generations to come. And if we still have a time, the lesson to learn from the past to improve the future, because we need it urgently. And I pass the floor to my colleague, Nejma from Miralab in Switzerland. Nejma.
Thank you, Marinos. Hello, good morning. My name is Nejma Kadi from Miralab, University of Geneva. So we are the technical partner in this scenario, and we are mainly working on digital human, virtual humans technologies. So together with my colleague, first with my director, Professor Nadia Manina-Talman, and then my colleague, Dr. Tiago Freitas, we are working together on this collaboration. So our aim here is to bring the historical figure to life in a virtual space and elevate the experience from a passive experience to an immersive simulation. And to show how the virtual humans can act as a mediator of history in this kind of situation. So the main items I'm going to present briefly, so the workflow, how we are collaborating with our partner, and where are we situated in this workflow. So how to go from partners input to virtual humans. The added value of our tools, speech synthesis, facial animation, and integration into our real-time engine. And how this workflow can be reused for other cultural heritage sites. So, oops, how can I go back? Voilà. Okay, so here from historical data to virtual experience, we present the workflow and the collaboration in this case study. So we have the input from our cultural heritage partner, which is CUT, donc Marinos, and all the data he has presented before. So we got thematics for the story, point cloud data of the enclaustra, and 360 degrees panoramic images of the enclaustra, and all kind of other data that we will receive in the next for the next step, like text and other stories for the narration. And so our role is to exploit all these data and to integrate them inside our tool in order to bring this experience. So the experience will be declined in three platforms. So we will have a VR experience, XR experience, and also a web-based experience. So once we receive all this data, we are we are processing this data, modeling and animation the virtual humans, and then we go for the VR implementation in order to get this virtual San Neophytos experience. So, oops, sorry. Okay, so here the historical thematics for the scenario will be, so the scenario will be built around 4 main thematics, like the construction of the enclaustra, the decoration, the monastery origins, and the transformation after the death of San Neophytos. So we are going to build our narration around these thematics, and of course we are mapping these thematics to the 3D scene and to the 3D space that we have received, and we will organize all this this story or this VR experience around this space and related to this 4 thematics. So here, from the data to virtual space, we see here so the different format we received. We have the point cloud, and we received also the panoramic images of the space and also the plan. So the thing is that for us, we are going to exploit all these information and try to restitute the best, the 3D space for the VR experience. This is our pipeline. So the pipeline is around it's the virtual human technologies. So we are first of all working on the modeling of the avatar. So we have all kind of process for modeling the avatar, the 3D geometry, and also the texture. Then we go for body and facial animations with voice and storytelling. Mapping a skeleton inside the static avatar in order to get an animated avatars. And then we go for the storytelling. So this is the third part of the pipeline. In the storytelling, what do we have? We have a lot of things. So we have text, we have speech, we have narrator, we have 3D building, we have user, we have user interface, all kind of things that we have to take in consideration to build this storytelling. And then finally we have our viewer. So we will have, as I said before, 3 kind of visualization: the VR, the XR, the mixed reality. Let's say it's a kind of AR but with interactions, and also the web-based application. The dual narrative approach, actually, according to the thematic chosen, so we will have all kind of generation of text. So, of course, we received text for the narration of for San Neophytos, but we also have produced some story with AI for the narrator's voice, because we think that it's very important to make a contextualization before going directly to Neophytos, just to have a voice that will say where we are, what we are going to see, etc. And also we have worked on the generation of the background sound to enhance the immersion. So the narrator will, of course, introduce the space. Then Neophytos will appear and will talk about the room, etc. And for the background sound, we have monastic chants to evoke the atmosphere of the monastery. So all these things, plus the 3D reconstruction, plus the 3D avatar, will give the sense of space and the sense of presence inside this virtual experience. So here we have the technique of text-to-speech. What we are using actually is from AI-generated sound, for example, for the narrator. So let's say for the narrator is something else. We are generating directly the sound, but for example, for Neophytos, we are receiving text or all kind of data that we are receiving for telling the story. So first of all, we generate the sound. So it's a synthetic sound. And then we put in this engine, we put the audio file and together with the text, and then we map this, we make a kind of fitting of the text with this audio. and it will generate automatically what we call the blend shape. It means that it will automatically animate the face and the mouth of our virtual avatar. So it's exactly this technique we are using to animate San Neophytos. And on the top of this, of course, this will give you the facial animation. But on the top of this, you have also to put the body animation. So for that, we have according to what he is going to say, we have to choose a set of posture, movement that fit with what he is going to say. Here, the exploitation and the integration of the point cloud and the 360 degrees data received from our colleague from CUT. And here you can see in the right side, you can see the integration of our virtual humans inside this 3D reconstructed room inside the VR experience. So here, the simulation, we have the web-based application, the mixed reality, and the VR experience, which is running in MetaQuest 3. It's the headset. For the web-based application, this is an ongoing work. So it's mainly developing with the Babylon GS technology for the WebGL-based, and we will get the 3D animated San Neophytos with a small graphic interface with a different kind of background and a small menu where you can choose what Neophytos is going to say and in which room you are going to play the experience, etc. For the second one, for the mixed experience, the mixed reality experience, this one will be conducted directly on site because we need to see the virtual humans inside the cave. So this normally should happen in the coming months, almost at the end of the project, because we have to go to Cyprus to test all the system there. So we will have San Neophytos appearing in each of the room and telling the story. And finally, this one, the VR experience that we can test together if you want, if you are interested by the demo. So this one, it's a VR, so it means that we have everything in 3D. The virtual humans and the 3D scene, etc. So you have a small interface where you can choose the different rooms, for example, and according to the rooms, the Neophytos will appear and will tell the story. And then you can see also, if you want to test the demo, you will see that you are completely immersed in this room. So it means that you can just turn your head and you will see that you are in a 360 degrees room. Why? Because we have combined actually the 360 degrees panoramic image sent by CUT together with the point cloud that has been transformed into geometry. And in fact, the fact that to use the point cloud plus the 360 degrees will give more the sense of the space. And even if the point cloud, you will see the geometry is not perfect because you have a lot of holes, etc. It's very complicated to capture with photogrammetry the complete space, but still it gives a sense of space and a kind of presence for this VR experience. So the contribution of MiraLab is the design of a complete AI-driven storytelling pipeline from text, audio, facial animation, VR integration, blending authentic scans with interpretive immersion. So we sell always interpretive because a lot of interpretation, of course, is taking part in this experience for the text, for the narration, for the way how we show the space, etc. And also enabling the museums to animate intangible heritage, because intangible heritage, of course, the fact to use virtual humans enable us to to animate intangible heritage, because the virtual humans is going to tell a story, and the story is intangible actually. So it's a way to preserve also intangible heritage through this population of with virtual humans. So the value for museums, I put museum, but it could be museums or other cultural heritage institution. It's the accessible and engaging heritage experience, the reusable workflow for any site. It means that here we have our core workflow working for Cyprus, but of course we can have it also for other sites. The institution, in our case, provides topic, scripts, 3D scans, or images, and we provide virtual humans technology, voices, AI voices, animation, and also the VR integration, for example, in this the case of VR scenario. You are welcome if you want to test the demo. This is the first result of the VR experience, so we are over there. Thank you very much.